right, I hope I'm recording. Hello and welcome everybody to tonight is January 13th, 2016, the vBrownbag US presentation. Tonight we're going to have Edward Haletky talk to us about adding security into Agile cloud development. Do you want to give us a little preview of what you're going to talk about tonight?
Sure, thank you very much. What I'm going to be presenting is how you add security kind of invisibly into an Agile DevOps type process, doing continuous integration and continuous deployment. And the idea is that if I can add it in quietly so developers don't even know it's there, I can actually open up the right cases automatically and have them work on it. And that way it doesn't get in the way. That's the whole idea behind it.
All right. Just a few housekeeping things before we get started. You can find him on Twitter at TexyWill, I think. Did I say that right?
You did.
TexyWill, all right. The other housekeeping things before we get started, we do have conversations happening on Twitter. You can follow us at vBrownbag. You can tweet the hashtag or # or Octothorpe, vBrownbag, and I'll be watching those for questions this evening, or the other global vBrownbag handles as well. Check our regular schedule. We have everything going on most nights a week, so if you have friends in other parts of the world that are interested, have them tune in as well. Again, like I said, we have Edward tonight with us, and I am Anthony Hook, and I wasn't sure if Jonathan Frappier was going to join us tonight. So far, no. So I will be hosting, and I think that's all I got. Thanks everybody who participated in Commitmas. I know that was a pretty big success this year. It was 30 days of learning Git and Git tips and tricks, and I wasn't able to attend because it's always a busy holiday, but the good part is everything was recorded. So thanks everybody for attending. Welcome to a new year. And I think that's all I've got. So I will be changing presenter to you.
Thank you.
You got it?
Yes, I do. Let me move this out of the way. Pick my app. And show it. Can you see that?
I indeed can.
Wonderful. So what I'm going to present tonight is a security architecture for Agile cloud development. And the reason why I call it an architecture, even though I've done some research on this, and if you guys participated in Commitmas, you know I actually did a demo of part of this, a small part that actually added a security measure into Git itself so that you could not export API keys and things like that. And that's available at that GitHub repository location. I'll be adding to that a little bit more as I go through the research, but a lot of it's already been done by third parties, so I should tell you where and when that is. I've written about some of this on the virtualization practice, www.virtualizationpractice.com. I'm always there, and as always on TexyWill just about anywhere, so you can look for me at those places. And by the way, if you have any questions, feel free to ask them, and if I see them, I will respond to them. If I don't, Anthony will let me know and interrupt anytime. That's fine. So the first thing is, when people look at Git, people first say, hey, it's just a code repository. A developer uses it. It's a repository. I may do some testing through it, or I may just hand off my code to a person that tests it through some other by hand waterfall type deployment session, and they copy the application, do some testing, and basically then they put it out in production. It's pretty straightforward. This is the standard way Git and code repositories are used. Not many people differ from this. In fact, I do it in some ways this way, in some ways I don't. But it's more than that, and that's the way we need to think about this now. It's also a build server. I add a build server into this, and what do I do with the build server? I store the results somewhere, and then I add it into the application and deploy it. And it's just a build. Well, it's more than a build.
I'm going to interrupt you just a second. Have you moved slides, or are you still on the very first one?
I move slides.
Okay, I do not see the slides yet. I saw your mouse move, but I'm still looking at security architecture for Agile development.
It must be not
Ah,
in the
there you
PowerPoint.
go. Okay,
Yep.
on the window.
So let me go back to the beginning for you guys.
Sorry about that.
This is the first page again, and it's just a code repository where we just have Git and developers and QA testers and so forth, and they all use the repository and they do what they need to do. Then we have other ones where it's just a build server. We have our build server we added in to we pull data from Git, build it, and then we do the same exact things with it. But it's actually more than that. When we do it, we can say it's just a process. I actually have a deployment process. I have a test process, and it actually all magically deploys from everything, usually in a fairly manual mode. I have one customer that everything's manual. Yet they use scripts to do the deployment, but it's not automated, as in the build is done, they do a deployment. They just do it by hand. They do, because they're so small, they actually do 2 or 3 deployments a week by hand, but that's for bigger organizations, that would just get a little bit laborious. So we need more than just a process. And wow, this is really not really showing up very well. Hold on a second. I'm going to flip to the actual PowerPoint. There we go. It'll be easier this way.
Yep, that works. I can see it just fine. I can see all the words too. We got our friend Kyle here, and he said brown bag moment achieved. So congratulations.
Happens all the time, right?
It does. It's always something.
So when you look at this, if I'm looking at it's just a process, I'm deploying and I'm doing a process for test, and then I may copy it out to production. It's all done fairly manually. When I start making continuous integration and continuous deployment, I have a lot more things involved. I have a build server. I may have an artifact repository where I put all my builds, the binaries. I have an orchestration server. That orchestration server may actually talk to the Scrum backlog, and then I use the backlog to sprint selections done manually by the developers and the infrastructure. But I'm adding in something called infrastructure as code. In other words, I don't just have the source code for the application. I have a script or some sort of code that deploys my application, all the servers and everything associated with it. I may be deploying Docker containers. I may be doing anything. These are things that we need to think about. But this is a much more automated approach. I actually duplicated this myself using Jenkins and Git and some of the other artifact repositories out there. And it works. I mean, I've been able to deploy, for VMware, I've been able to deploy VMware Photon with a Docker container for LAMP stack, and it works great. And it's all 100% automated. I can deploy thousands of those if I wanted to. However, that's not necessarily secure, it's just deployment. I take my infrastructure and I deploy it out. So the first step in making this really secure is to expand what I consider to be code. It's not just infrastructure as code or the source code to the application, it's really security as code. I have a security developer or the security engineer adding into the infrastructure the bits to secure the application, the bits to secure the underlying virtual machines or containers that I'm putting out. In other words, that code gets deployed with the infrastructure as code tied together to deploy a secure application. And that's the first step. The security developers are the ones that need to do that, not the actual application developers. And the infrastructure as code guys are really just the admins. They're just scripting things. But there's a lot more to this. This is the first step. And some people can't even make it past this step. The next step is to actually do what I call static code analysis. And I demoed this at Commitmas, so you can actually look that up on YouTube, where I added in to the pre-commit hook for Git, for my source code repository, an analyzer that looked for personally identifiable information. personal health information, credentials, API keys. You can even add into their coding, security coding errors like buffer overflows, and the common things like SQL injections, the common attacks that are part of everyday life. Now, if I'm a security guy, I want you to use this because you put out API keys, that costs me money. If you put it out there and they pick it up out of GitHub, they now can log into your Amazon instance, for example, and start up any number of processes and cost you thousands of dollars. And then I need extra monitoring to prevent that or to make sure I catch it in time to shut things down. But they can even do worse things than that. So this is another step that allows me to prevent you from putting things out. This is kind of what I would say the bare minimum. Put it as part of the commit part of Git so that it actually never even enters the repository. It gets rejected and logged. And why do I want to log things? Because if I don't log them, I cannot find where the mistakes were made, who made them, so that I can get further education for the development team to say, you know, this is really not a good idea. You know, those are the types of things. And also, since it deals with API keys, credentials, PII, PHI, those fall under compliance. And compliance is really interesting to make sure those don't leak out. So now I've added in something very quiet, very subtle, that allows me to do something pretty nice. And this is automatic. I've already written code to do this. You guys can pick that up at that GitHub repository. But it's behind the scenes. I don't have to train the developer to do anything. It does it automatically for them and gives them a warning saying, you know, there's an API key in there. Now they can force it to happen and bypass this, but I've logged it. There's an API key. I know where it happened. And they want to remove that. And it's something we've been trying to teach people to do. That may be enough for the security as code guys to go and say, let me update the script to catch even more things. And again, it's just a script that's part of Git. I've added it into all of mine, and you can add it into all of yours. The logging of the results for my orchestration for my build becomes tied to my Git commits, and I want to log all those too. And that way I have a pretty nice flow of what's happening so I can figure out from a security perspective or even from a compliance perspective or even from just a developer's perspective what has happened. Someone submitted a bug report. I may want to trace it back to say, well, where's that happening? Okay, it's happening in that code. Who was the last one to submit it? Let me figure out what they last submitted. That way I have a refined way of looking at things. If I'm not logging that, I may never know. Now, Git has all sorts of ways to say, give me a diff, give me all this. A little logging goes a long ways. And the other thing is because I'm logging it and I got this code analysis going on, if I've got coding errors like the OWASP top 10 and so forth, top 20, I could actually open up issues automatically. Open them up in some sort of issue tracking software in an automatic fashion so that they are part of the backlog so that the next sprint happens, they may or may not be picked up depending on the selection criteria. But I've actually put them in there in a nice way. And I've actually gotten it in there so I don't have to worry about forgetting it. Oh, that happened. No, I want to actually log all those results. And I can do that by looking at the coding errors can automatically do that. I could do it as some sort of analysis on my log repository through Splunk or whatnot, and I allow it to go in, and I now have a nice way of tracking issues. Again, the developer doesn't even know it's happened other than the initial warning. It shows up as an issue so that they can decide when to fix it, and those will be based on business needs more than anything else. But if I don't log it, I don't open an issue, it gets thrown by the wayside, it gets forgotten, and I still need to do that. I need to fix all my security concerns if I have any. So if I want to look at coding errors, there's actually some nice tools from HP, or you can get stuff like RATS and a few other static code analysis tools that are available for whatever language you're looking at. And I'm looking at about 6 or 7 public domain ones that you can look at, RATS being one of them, and actually RATS ended up being bought by somebody else. So you actually have to look for it. And I'll have some links available through the vBrownbag. When it goes up on YouTube, I'll put them up there. But there's some nice tools out there for any language you want. If you do only Java, great tools for Java. If you do PHP, some tools for PHP, C, C++, even Fortran. So it's well worth putting in there and just having it look at the code and say, hey, did anything change? Did it cause a security problem? Should I actually, is it severe enough to say it must be fixed before you can submit, which would be nice, but it would be getting in the way, or submit, log, open a case. So that's not in the way of development. It gets picked up on the next one. So those are things to think about with that particular aspect of this. Now the next stage is actually preparing for an automated test. And why do I want to prepare for an automated test? I'm now adding into my code, testing as code, and the data for the test. And by preparing this, I actually again use a precommit hook to capture from the captured data to modify it so I can do dynamic testing. So I have a proxy involved now that actually sucks down every request made, and then I can go through and modify the request to put in the dynamic testing bits for whatever dynamic testing engine I'm using. If I don't do this prepare stage, I actually have to write all my tests by hand, and that actually gets laborious. I'd rather actually capture the test. I do some initial test, I capture it, and now it becomes code. I can then automatically do my test and my security testing based on all this data. I can literally take that data, put in the right bits for, like, for example, if I'm using Ixia Breaking Point, which is another tool you can use, and they have a virtual version which is very nice, and it does run in Ravello if you're using that. I can actually then put in the right code, and it's actually automatically, it says, oh, IP address. Well, I can put in a range of IP address. Input, I can actually fuzz that input with any number of characters, numbers, letters, whatever I want to put there. Oh, a UA, a user, I may want to change the UA. And it works really well with web-based services, which is really what the Agile Cloud puts out. Also works for just about any API, because I can fuzz the input by changing what I originally tested for stuff that is random. And I want to do that to capture long, very long, see if I can pass a very long URL or a very long field. I want to be able to put that in there. But I need to prepare to do this. I actually have to do a little bit of by-hand stuff up front. But once I do this, I can actually improve my pre-commit hook for the modify the test data as I get comfortable with the language. So that's the second part. I would put some security in here, and that is to actually add fuzzing techniques into my testing. Once I have that, I can automate my testing. In other words, I could automatically use my orchestration server to build and deploy into a test environment my application. I can attach it to the test rig, whatever it is. Ixia is one, and there's a few others. Spirent has a few. And then I could run my test that I actually saved as code using the data that was automatically modified, and it will run at line speed. So I can actually do it. I actually did this for a test when I was doing some testing for them, and actually built out the process to do this. It actually was able to run 110,000 queries. No, actually, I take that back. 210,000 queries in a minute. And it was a fuzz test. So I was actually fuzzing the input to ensure that it handled it. It handled 160,000 of them were great. The rest of them were broken. So that told me that either the server that I deployed could not handle the workload, which is a good thing to know, those upper boundaries, and it also could tell me that they failed the fuzz test. I didn't get a result that I expected. And by adding in a nice little automated testing, I've actually used the exact same thing I do for CI/CD, but I've just done it into a testing arena. And this little area where I just had the test rig and the application, and it's separate. It's put to the side of everything. It's not part of And then once it not part of production, once it passes, or if it doesn't, again I open up issues, the backlog, to sprint selection happens, and they get selected or they don't, based on the business criteria. But I've actually automatically logged everything to the log repository. I've opened up issues based on the results of those tests, and everything can be automated, including the output of the report, the storing of the report in the artifact repository if you want, the running of the test, the fuzzing of the data, and then from there I may say, oh, you know, I want to run this new test that does SQL injection. So why don't I modify the pre-commit to capture all that? And I can actually capture it from the testing arena as well as from production or from a staging area. And that gives me a nice little added bonus. This is much more, adds a lot more to it. I'm not just doing testing for security. I'm doing bandwidth testing. I'm doing testing of the application in a much more automated fashion. And I call this more, I mean, I need to do those because right now, unfortunately, in a lot of the web world, they do something called A/B testing, where they actually put out in production to a subset of the customers a new deployment without really testing much of it in-house, because it's the testing at scale that becomes a problem. Well, I'm sorry, but your customers of products are actually getting tired of being your beta testers, because when things fail, if they can't get their jobs done, they don't like it. So if you actually put a testing rig together with a testing environment, you can actually do scale testing in a matter of moments. Some say, oh, a minute's too short. Well, make it 30 minutes, make it 60 minutes, make it as long as you feel comfortable. A minute or two is actually enough from a security perspective to tell me whether or not that fuzz test failed. And if I'm doing a specific test, I know which one failed. I can run hundreds of these right after another. I can say, okay, the first one's a fuzz test of this input, next one of this input, and next one is combining them all. I could also then do, oh, let's do SQL injection, let's do, you know, cross-site scripting attacks. Let's do any number of 6,000 plus attacks that are inside of the Ixia's breaking point at any time, and a minute's enough for each one of those. That means I have 6,000 minutes to run? No. I pick and choose based on the application the ones I really need. Some just don't apply, and you need to be careful of that. So these are 3 places you can add in security in a nice little automated fashion. And again, the developers don't even know I need to know I do this. It just becomes a criteria for proceeding to the next step. So I've actually done testing as code where I've done my build server. Let's say I'm using Jenkins, and that's the one I use. You can use Ansible or any of the numbers of ones you want. One of the build steps is automated testing. If it passes, it goes to the next step, which is deployment, which is a very nice way of doing this. Now, I really want to add in some level of dynamic code analysis. This is the next thing. I've done static code analysis, but I want to actually put in a little bit more dynamic code analysis. This isn't testing so much as it actually is inspecting the code, either the compiled code or the bytecode or the prepared code that's going to be released, to look for dynamic issues. It may actually run the code through a virtual machine to ensure that there's nothing that's going underneath or something that's breaking. It may be looking at the Docker container that you're in and looking at the infrastructure and saying, okay, let me run it, or let me investigate it in its built stage to ensure that there is nothing wrong. Static code analysis picks up some things, dynamic code analysis picks up others, testing picks up a lot more. And these 4 things I put in are independent of the developers. I've just done them as part of doing my security. It's invisible until they show up in the issue tracker, or whichever one, or the Scrum backlog, to be fixed. They don't even need to know they're there. Now, I want to be able to educate my developers to be better, or my infrastructure developers, or my security developers, or my testing developers to do better. And this gives me an opportunity to provide them a much better way of educating them. Why talk about, oh, it's an identity issue, it's an API key issue, when that's not really the problem. It may be, oh, a cross-site scripting attack that you need to really say, okay, this is how you defeat that. Or you may need other ways of putting out and doing deployment that are much more secure. Now, there's another piece to this that's actually rather subtle, and this is kind of completing the cycle. If I have a web-based application, I generally have some sort of application performance monitoring tool like a New Relic or a Dynatrace or something. I may even do log analysis using Splunk or Log Insight or any number of tools. And I may be doing security analysis. I want to go a step further, and I want to actually tie that in so that let's just pick on application performance monitoring, that my application performance monitoring server that's actually monitoring the application in production is actually the same server that I use to monitor the application in test. I'm just looking at a different part of it. And that feeds back into the orchestration server to say, hey, I need to deploy these bits for the APM tool, or I need to actually open up more logs or more issue trackers because I have a performance problem, and that performance problem could be for any number of things. But if I don't do the same thing I'm doing in production, in test, I'll be missing some things. I want to make sure it works at scale. I want to make sure nothing is broken. I want to make sure that the new feature didn't just sort of kill performance. And if I kill performance, I can actually determine that through a number of different ways. Was the performance killed because of a security issue? I want to find that out before I put it out. Because if someone actually does attack me, and it's not a question of if, it's a question of when, I want to be prepared to know how to solve that. I want to be able to look at it. Or I may say, you know what, I think that's a 1 in a million chance. It's not really a big risk. Let's put it in the Scrum backlog and, again, look at it for the next sprint or a few sprints down the line. You find out it is a big issue, you at least have it in there so you can actually fix it in the next sprint. All of this is automated. And I've done all of this, actually, in one of my own environments.
Along those lines, sort of, kind of, we do have a question.
Sure.
Do you have a common framework for all of these different components?
For the static code analysis, the framework I use is actually built into Git. It's called Precommit. It's a hook that you can actually use and write your own scripts for. There is no scripts pre-written except for the one I put out already that I know of. So I'm actually using Git as the framework and hooking into it to do what I need to do. That could be modified code on the fly. It could be looking for things. For the dynamic code analysis, there's a number of different security tools that actually do that. And those are the ones that they have their own frameworks. Again, you need to actually do some scripting in your build environment, whatever that build server is, to automate this, or the orchestration server. And all of them have APIs. So if your orchestration is Puppet, go for it. It's all built into there for a lot of things. If your orchestration is Jenkins, that's more of a build environment, and then you call out to an orchestration server to do the other bits. For testing, I actually like Ixia. Ixia Breaking Point is a nice framework. It's a little clumsy at the moment from a scripting perspective, but I know they're working on it. It uses a TCL backend for scripting. I know they're changing that. So it's something to think about for that. Spirent is another testing engine that you can use, and they have their own APIs as well. So for me, it's a kind of a combination, but I joined them all together using the build server. And for me, that's Jenkins. I just log in the Jenkins, the pre-commit's already there, actually pull everything from the repository. I can then do another scan at that time, a static scan. If it doesn't pass the static scan, I don't do the build. Because remember, all these pre-commits, because of the way that it gets designed, can be bypassed. For log analysis, I like Splunk and Log Insight. I use both. For application performance management, it really depends on the APM tool that you're using in production. Pick the one that actually is there. Don't try to use a new one. Does that answer the question?
I think so. I haven't seen any follow-up to that one, so I think so. We did have another one that just came in. Beyond reading Jez Humble, which additional resources to read up on general integration testing, unit test, exploratory testing?
Well, I think this goes a little bit past all of that. I mean, there's all sorts of forms of testing. The developers have to do unit testing before they actually put their stuff in Git. If they're not doing that, that's just something that they're actually, they failed. I'm sorry. You need to go back to Development 101. After you get to there, yes, there is QA testing, and they should be doing that, and they have their own set of tests, but it's generally not in an automated fashion. It's usually a human being running testing. But what I've done with QA is I've actually said, okay, QA, I'm going to capture what you're doing through a proxy server before you hit the environment, and then I'm going to modify it to do testing as code, and that's what I'm using in the testing environment. So I'm actually starting with what QA does and then adding to it, so eventually I have an automated QA environment for what's known, and that allows my QA testers to actually develop new tests. They don't actually have to run the old ones over and over and over again. They can develop new ones that fit new criteria. And that actually leads to a much bigger environment to test, and you actually get better code coverage. And also, I may have a proxy for A/B testing. I may actually, for my A or my red, green, A/B, whatever you're going to call it, I could put a proxy in front of my A's that the new just went out, capture all that, modify it, and it becomes my testing, because now I have real-world results. I'm using whatever happened in the real world. Now I have an automated tool that I can actually modify those, and my QA testers and my test developers can actually look at that and say, okay, let me change it to this instead of being this automated change. We're looking at this specific thing. Let me add in a new one. And that gives them the ability to do that. Once they add in a new one, figure it out, make sure it works, then it becomes part of that pre-commit hook series of exchanges that has to happen. This is a new way of doing it. Every time I look at people that are doing Agile, unfortunately, testing is unit testing and then put it out in production. I mean, they're so fast, they say, okay, I got to do 7 releases in a day. You know what, I'm going to do my unit test that passed that. I did a small test of 1,000, 2,000 sessions. It kind of passed that. I don't know how to test at scale, so I'm just going to throw it out in production with an A/B. Once I throw it out in production, it either breaks or it doesn't. If it breaks, I got to fix it and throw out a new one and do a new release. In this way, I can at least do some level of scale testing and some level of scale security testing without using production as a test engine. It just adds in a nice little feature for that. And I think that's a very important piece. Now, are there public domain versions of test rigs? There's a few out there for various web servers, but you need something that can duplicate 100,000 sessions in one go using multiple IP addresses. So you don't have to worry about caching in the server and all that. So keep alive is not necessarily, maybe a problem, may not be. You need to kind of duplicate and replicate what happens in production, which you don't have the same IP hitting your servers all the time. And that's what these test rigs do. They emulate all that. As for references, this is fairly new, to be honest. There is static code analysis references you can get from HP, for Fortify. There's a number of other ones you can get off the web. I'll get links for those. The dynamic code analysis, there's actually references for various tools that do that automatically. For testing, there's security-specific testing like Metasploit and so forth, but there's actually, Ixia has a very wide-ranging library, so does Spirent, to do their test rigs. So they actually have a lot of resources available to them for that. And I wrote an article using adding security, testing as code, and actually a white paper on the site that you can read as well. That goes through all this, a lot of this process, specifically around testing. So those are the references that I know of, and I'm constantly looking for more. Believe me, This is a new and interesting area for me. I think for everybody, because we're deploying way too fast. And we need to get our hands around it to make sure we don't put out anything that's broken, because even for 10 minutes, if I just leave something out there for 10 minutes in a broken state, I could have $1 million breach. And that would be really, really bad.
Well, and it kind of goes, you said it's moving fast. It kind of goes along with the, release early, release often model that a lot of, even small, startups or, companies are using. They are releasing early and very quickly. So, things like this is, very important.
And I'm not trying to slow anything down. I want them to release early and often and so forth. This is just saying, hey, if I can take a minute to at least run one security test, that'll give me an idea of whether or not it'll handle, A, the scale I'm looking at, and whether or not, it's going to be attacked by some well-known attacks. And if those are going to be valid, you got some problems here that your code will not survive. Plus, think about it this way. If I don't do scale testing at this level and I'm actually going out to put something out for Black Friday, it behooves me to test, because a couple of years, actually last year, 2014, over Black Friday, 8 or 9 major companies in Europe went down because they didn't do any testing beforehand. They just said, oh, Black Friday, got some new code, going to put it out, done. And their sites all went down. They lost lots and lots of money because they could not handle it. They had everybody on deck to fix it, and some of them fixed it really fast, others did not. And that would be a really bad idea. A little testing like this would say, okay, that change allows me to scale up to 100,000 sessions per server. During Black Friday, I normally get only 50,000 per server, and I have 100 servers. I'm covered. I know what my breaking point is. And that's kind of the goal. But if I say I can only handle 25,000 sessions, I don't have enough. I may have to deploy more of my application for Black Friday because I just can't handle the load. And that's a good thing to know as well, because that goes back to the orchestration and says, hey, I can't handle the load. We know this. When we deploy this new version the day before, let's deploy 200 more servers. That'll handle the load we need. So it's actually all tied together in a very nice way. I just kind of put a bow around it.
Yeah, that's excellent. It's a lot of information. I'm not really in the development world in what I do, but I do see what happens when things like this doesn't happen. But I can even understand this on a small scale where I'm doing a small GitHub project and I commit it, and I always check to make sure I don't leave any API keys in there or anything like that. So even on a smaller scale, if you don't have anything, that I would consider this to be a large setup anecdotally. But it is important to watch what you're committing. Make sure you don't have usernames, you don't have passwords. Just
Absolutely.
Little things like that, even on a small scale.
Now that, I'm going to go back to the front page here. That is actually at this GitHub repository. You can get that, and that actually has the Precommit Skip that actually looks for all that. It's already ready. You guys can download it, follow the instructions for installing it, and you're good to go. It'll do all that for you and warn you. I've actually used it myself, and I continue to use it. I actually use it on this repository to ensure that I'm not putting out anything I shouldn't. And then it catches it, and it's very nice. So that part for everybody, this is actually a no-brainer type of let's put it in there. Now, for doing static code analysis, that's actually valid for everybody as well, because you really don't want to do things that have buffer overflows or using bad practices from a security perspective, or even just from a coding perspective. They capture all this, and it's also worth having as well. Again, static. Actually, my next one is to put that up there, so you actually have a public open source static code analysis tool that you can hook into. As for the scale testing, actually, anecdotally, it's actually not for big businesses only. It's for everybody. I know some medium companies that use it now, and I know some small companies that use it, because size doesn't matter. Your footprint online If you get slash dotted, for example, you're going to actually end up being majorly hurt. Your site will go down. That would be bad for business, even if you're small. So you need to think about how you're going to use this. And just doing any level of testing, even if it's just using Apache Benchmark or some of the other tools for Nginx, you really want to look at that. For even if you're small. Even if you're doing it in open source, even if you're just running your own blog locally, you may want to run these to make sure you can handle the number of users and sessions you want to be able to handle. Now, security testing, that's a different story. Most small businesses need that. I haven't seen it yet in a lot of them. So you got some really cool stuff that you can do, and I think this is something that's, the architecture is geared for everybody. You plug and play the parts you need. If you look at this from an architecture perspective, you know, not everybody needs all of this. But I think everybody should consider all of it and pick the pieces they need. So the main thing is to complete the cycle and make sure you do everything in an automated fashion.
And if anybody wants to, I just tweeted it, hashtag vBrownbag, that link that you had up on the first with your AAC pre-commit hooks. So that's excellent. I'm going to have to check those out myself.
And that's what I put on. I did during Commitments. There was actually a demo bit on YouTube for Commitments, so you guys can look at that. I ran a demo. It was very, very short, and basically I showed you the script. I ran the demo, and it showed me trying to commit like several API keys, several passwords, and a credential. And those are bad things. And the script actually took me about an hour or two to hour and a half to write, because I used a resource that's actually listed there that had all the regexes already written for me. So all I had to do was just pull them down and copy them and put them in some sort of order that made sense. It even looks for Indiana driver's licenses. Don't ask me why just Indiana, but that's all I had access to. If you want to look for every state, go for it. You can find that information. And this is kind of what the hackers are doing. They're looking at your everything in GitHub and saying, hey, did you leave me any juicy information? So it behooves you not to put it in there.
They will find it. Security, security by obscurity, pretty much everybody knows now that doesn't happen. Even if it's a small project, you have to make sure that you keep it safe.
Exactly. You have to be able to do that. It's the bare minimum. I would start there. The rest of it is something I would add in as time goes by if you're a small company, but that actually is a money saver. That will save you a lot.
Absolutely, and a lot less headaches down the road if anything does get taken.
Yes. Now I've added in logging, and I actually like the logging aspect because then I could pass that to my SEIM for security analysis. I can put it into my Splunk for enterprise security analysis, or I can put it into it and just say, okay, now let me look at this and figure out what education developers need when it comes to security. Or I may just say, in general, they're not abiding by my coding standard, which I could actually scan for. That's something that needs to be fixed. Or it could be they don't actually comment enough. You can actually look for that. Is it commented well enough to understand it? So that every company has coding standards. Even though we're going faster and faster and faster, doesn't mean we should overlook the things that are required by the business. Just because we have to go faster, we have to do it the right way. And this, you can actually look at this and say, hey, what's happening overall? How well is development doing? How well is testing doing? How well is infrastructure doing? And you can get all that information. And from a compliance perspective, that's just golden. From a management perspective, that could be very useful as well. And even the developers should be looking at it, because it'll give them an idea of how well they're doing and whether or not they need to change their behavior, or they need to go and say, I need an exception for all of this, because I got this project due and it's getting in the way. The idea is for it not to get in the way. So it should not deny as much as it should log and warn and allow people to get some idea what's going on. But also the key is, to me, is just being able to log into the backlog new requests. That's kind of been crucially missing. It has to be automated. Automation is king. In this case, it really is.
Excellent. There's a lot of info. I was just going to ask that. Any other questions? Anybody in the chat? I didn't see anything coming on Twitter yet. Anybody? Last call. Anybody have anything else?
I have one more thing to add. I actually will be, if people are up in the Boston area, there is a conference called Cloud Security World, and Agile Cloud Development in Security will be a major topic there. So I'll be speaking there as well on the subject. So it's something to consider for the future if you want to get some nice hands-on, in-depth, more in-depth than this. And by the way, if you have comments on this architecture, you think there should be something changed or added, please let me know. I'm always willing to do that. You can find me on Twitter at @TexieWell. You can find me on a number of different forums. If you want to talk over Skype, or you can find me via email as well. And you can find me at the virtual practice.
One last question here. He said, great stuff. So how soon can we expect a definitive TVP ebook on the subject to be published?
Working on it, actually. I'm working on a class, actually, on this, so that will come out first, and then there will be a nice little write-up on there. What's coming out of TVP next is the version 2 of my secure hybrid cloud reference architecture. Some of this is mentioned in there, not a lot of it. That's something else, and then I'm going to actually start working on, I got 3 or 4 other things I have to write first in order to build up to this, because there's a lot of underlying concepts that need to be looked at. So I plan on, hopefully I'm going to plan on trying to say by VMworld. How's that? That's my goal.
Yeah, we'll see if Kyle holds you to that or not.
Kyle, you can hold me to it. It's just I'm hoping by VMworld. It just depends what ends up on my plate. If anybody's going to be at RSA conference, I'm going to be there myself at the end of February. V2 of my secure hybrid cloud reference architecture will be coming out before that, and will be available at the by RSA. The workshop that I'm working on that's based on this stuff will be at Cloud Security World, so if anybody's interested, there's a link on the site, or just get in touch with me and I'll get you in touch with everybody there. And I'll be up in Boston, so I'll be glad to talk to anybody as well while I'm there. And I'm also going to be at InfoSec World, and this is part of a model I'm putting together for putting things securely into the cloud. So there's a lot happening, quite a bit happening in this space right now. At least for me, it's fascinating.
Well, it's a relatively new space to be in too, from my understanding. So
yes,
it seems like a good place to be.
Absolutely. There's a lot to do. There's a lot that has to be written still from a coding perspective. There's a lot that has to be researched to write that code. I've done the first part and the testing part. The dynamic code analysis is actually next on my plate. Or more to the point, I'm going to actually be putting up on the AEC lib. It's my consultancy's library of tools for Git. I'll be adding some more into that, specifically around testing. I may even adding my Jenkins builds so that people have something to follow. And then they can map to themselves. But I'm slowly figuring out what I can put up there that's understandable, and a few other things so that people can deploy what I'm talking about. That's the key. So I may end up having some automation scripts up there as well, things you guys can pull out and use for your own uses.
We happen to be a big fan of community-oriented stuff too, so I'm sure everybody appreciates it.
As I said, give me ideas. If you guys want to see something else in this, let me know. It's cool. I'm open to all sorts of ideas.
All right. right. If there's no other questions, thank you very much for that. I learned a ton. It's not even my field, but I learned a ton, and I'm sure everybody else did. For anybody else that's here yet, if you want to catch up later on this, rewatch it again, it will be uploaded to YouTube and our iTunes channel. So subscribe to either of those or both if you care to. As always, you can hit us up on at vBrownbag or use the hashtag vBrownbag on Twitter. Otherwise, I believe our next show will be next week, unless I'm wrong. But keep an eye on the website and our Twitter feed for anything. I've been known to be wrong on the internet before. It's just not always recorded like this. So, so I'll be wrong for all of the world to see, which is okay.
Well, thank you guys for having me. It was a pleasure.
Yeah, thank you very much. There was a ton here, and I'm sure you'll get some follow up, and we'll be in touch with you on some follow up and maybe a slide deck to post as well, which actually you already got me. So.
Well, let me give you a new one. I had to fix it, so let's go ahead and do that.
Sounds good. All right, thanks everybody for attending, and I'm going to stop recording here as soon as I figure out